2010.
2010. This was an interesting. So this is before the Christchurch earthquakes. So there's some big earthquakes in New Zealand that decimated one of the biggest cities. And this is before that. And what the context was that the New Zealand government wanted to encourage. New Zealand grows a lot of pine trees. This is what the timber industry comes from, and they wanted to establish a way of bigger buildings being made out of timber. So they ran an international design competition, not a national design competition, to make an art school, but in a way that was out of timber. And we
should never have won.
No, of course we didn't. But we entered, and we had this very simple idea that so New Zealand has these big earthquakes. If we could just control the earthquakes in a few places with some new science that was being developed out of the University of Canterbury, then the rest of the building could just be like a really big house. So that we really simplified it. So, and that sort of allowed us to say, one, we're going to make this building incredibly legible so that the New Zealand timber industry can go through it and can understand how it works.
Yeah.
And it all looks really, really normal, just like you've blown up the detail on a photocopier, 500%, because everything's big. But in a few key places, there's some really, really high-end science about post-tensioning, which has never been done before anywhere in the world, and is allowing the building to be made in this very simple way. And you probably should talk about that, Andrew, but you solved it.
Yeah, I guess the thing about the building is that it has to be more than just the engineering, otherwise it's not architecture. And I think that was the trap at NMIT, trying to avoid it just being an engineering exercise. And so that notion of it being a big house, the other word that the government used at the time a lot was a landmark building. And I think that's one of the reasons we made it through the competition too, Jeremy. I think the other architects interpreted landmark as a chance to make something iconic. And I think the design philosophy that drives this is that a landmark might just be a point in the road that shows you where you can go. So it's the notion of this building is that it's made with simple technologies, other than in 4 key places. It's made in a provincial centre. It's not made in one of the big towns, and it's made in a way that local contractors could do it without having to bring in someone from a bigger town. So those decisions drove the way we thought about space and we thought about detail. And so the kind of the design aesthetic or the building that comes out of the other end reflects that. And it's about thinking and designing reductively in that case. It's about thinking about what do we need, where can we stop, how can we make it so that it's A, we can build it, and B, it looks effortless. And there's an awful lot of effort in making something effortless, we learn. And the great thing about NMIT, maybe the thing that's informed the places that have come afterwards, is that it didn't really matter what happened outside. There were some key things that we wanted to happen outside. One is there's a wall that faces south where we needed to have the angled curtain wall, and that was that notion about seeing inside, about making what happens inside the building public to the street. It was one of the first times we thought about that. The other key thing was having an enormous overhang to the north so that we could really simply control the environment. And after that, once we got those 2 things, as we discovered over time, we could let go of almost everything else, and we did. So again, it's just got roofing on. It's clad in white roofing in the same way that Gisborne's clad in black roofing. And the key is that it doesn't matter.
It didn't have it again. It doesn't. I guess our approach is to say, like we said earlier, is to put your money where it matters. And on a building like that, it's one, it has to be landmark and showing how to build multi-story buildings out of timber. But secondly, it's a community art school. It's where you go to, to learn about making art, and you might be doing it as a kind of a tertiary qualification, but you might just be there doing an evening class in bead making. So it has to read as homely and feel familiar and invite people into an education environment that they may not otherwise do.
Yeah.
So, and that's where the timber, lovely, because it was warm and smelt good, and it was sort of familiar. Yeah. So, and I guess the other thing was interesting was that we resolved a way that all the timber in that building was it 80 kilometres? It was grown, milled, prefabricated, and erected all within 80 kilometres. So everything came from incredibly kind of sustainable, low transport things, which was interesting. And you probably wouldn't be many places you could do that, but just it happened that the place that they chose for the building had this resource that we worked out. So it was quite a nice thing of saying it's a community building. It's all from your community. The whole thing is coming from this little.
Yeah, kind of the choice of material and the decisions we made embed it in its place. And so one of the great successes of the building, but one of the great failings for us is I think we're up to 161 tours of it. Various people come through it, and the people that come to look at it aren't the people you'd expect. We get loggers and sawmillers who are interested in the notion of what an end product from their process or from forestry might be, other than cutting down a tree and putting a log on a ship and sending it to China. And I think that's part of the success of it. It is still pointing a way that we can do more.
And from there right through to international engineering conferences that we had in the building, because it's done something it's done something that hasn't happened before, and that basically the timber structure's been post-tension, so it's got high caliber wires going through it that get cranked up. And so that after in a way of rocking, so the building has a place that controls how it rocks. And so after an earthquake, it rocks, but then it comes back square. So this was all before the Christchurch earthquakes. And after the Christchurch earthquakes, of course, it became quite important. Suddenly people go, crikey, this is actually... And so it's sort of the idea of damage avoidance design. So parts of the building, you control where it's going to fail, and you make that bit replaceable. But the structure is okay.
Yeah. So the intent is that after a Christchurch scale earthquake, I think we'd have to replace 30 small pieces of steel, which are the engineers call them a fusible link. So it's exactly the same notion as the fuses in your electrical board at home. Too much force comes into the building, these things fail, and they stop the force going anywhere else. And it's a really simple idea, and it has had quite a bit of take-up in Christchurch. This notion that you can have a building that, rather than having to demolish it and start again, you can spend $100,000 on bits, and you're back to square one.
Yeah. So we call that kind of we call that our sort of generation one timber structure. It's the first one. And what are we up to now? I think we're up to 5.
5, yeah.
So we've done a series, and each time, because it's new and it's never been done before anywhere, that they just keep getting, the system keeps getting slightly better, but it keeps changing because you have different contexts and different neighbours and fire rating issues and things to control.
Yeah.
But we're progressively doing these buildings, and we've got one of 2 buildings that we're presenting at the World Architecture Festival this year is our latest one. But it's the same idea. It's about stripping it right back, making it really simple, not making it harder than it is. And then you need some really high-end science, and you put it in a few key places and make it understandable how it works. So we like to hope that anyone coming into the building, even if they've got absolutely no understanding of what it is, but they'd be able to understand it. They'd be able to read how things work, and then you can do that.
Yeah.
Yeah.